Hey everyone, and welcome. Today we're diving into two pieces of tech that are totally changing the game for how our favorite video games look and feel. Variable rate shading and mesh shaders. Seriously, this is the secret sauce for next-gen graphics, so let's get right into it. You know the drill. Every single gamer has been there. You get a brand new game, you're super excited, you jump into the settings menu, and boom, you're faced with that classic, agonizing choice. Do I crank everything to ultra for those gorgeous jaw-dropping visuals? Or do I tone it all down to get that buttery smooth frame rate? It feels like a constant compromise, right? But what if I told you you don't have to choose anymore?
Okay, so to really get why this is such a big deal, we first have to understand the core problem. At the end of the day, modern gaming is a giant performance puzzle. And the most important piece of that puzzle, your GPU, the graphics processing unit.
Just think about this for a second. A 4K screen has over 8 million pixels, and your GPU has to draw all of them, maybe 60, maybe 120 times every single second. Now add in thousands of 3D objects, super complex lighting, realistic shadows, you get the picture. The workload is just immense. Pushing for more and more realism can bring even the most powerful graphics cards to their knees, and that's when you get that stuttering, that lag that we all absolutely hate.
For a long time, the only real answer to this problem was just more brute force. Bigger, faster, more expensive graphics cards. But now, we have a much smarter way of doing things. We have two incredibly clever solutions that work together to make the whole process way more efficient. Let's break this down. It's kind of like a division of labor. On one side, you've got variable rate shading, or VRS. Its job is to work smarter on the pixels, the flat image you see on your screen. And on the other side, you've got mesh shaders, and they work smarter on the actual 3D shapes in the game world. The easiest way to think about it is this. VRS handles the painting, and mesh shaders handle the sculpture. All right, let's dive into our first solution, VRS, and see how it so cleverly manages all those millions of pixels. This is where the magic of work smarter, not harder, really kicks in. The whole idea behind variable rate shading is actually pretty simple. Not all pixels are created equal. I mean, some parts of the screen, like where you're aiming, are way more important than, say, a blurry background or a dark corner. VRS lets the GPU finally understand that difference, so it can stop wasting precious power on details you were never going to notice anyway, and focus all that effort where it really truly counts. So, traditionally, your GPU is, well, it's a bit of a brute. It doesn't think, it just does. If it sees a little block of 4 pixels, it performs 4 separate, really intensive calculations to figure out the exact color for each one. It does this even if all 4 pixels are basically identical, like in a deep shadow or an out-of-focus background. It's just wasted work. And here's the aha moment. With VRS, the GPU can look at that same block of 4 nearly identical pixels and basically say, you know what, these are all pretty much the same. I'm just going to do one calculation and paint all 4 of you with that result. And just like that, it's done a quarter of the work with practically zero difference that the human eye can see. It's brilliant.
And this all happens in a crazy fast 3-step process for every single frame. First, the software quickly analyzes the image and finds the unimportant bits. Second, it creates something called a mask, which is really just a simple map that tells the GPU, hey, go full detail here, but you can take it easy over there. And finally, the GPU just follows that map, saving a massive amount of power.
All right, so we've made the pixels way more efficient. Now it's time to get smarter about the 3D objects themselves. And that's the job of mesh shaders. So if VRS is all about how we paint the final picture, mesh shaders are about how we build the 3D models in the first place. This tech is a complete and total overhaul of the old, clunky, rigid way of processing 3D shapes. It makes the whole pipeline way more flexible and way more efficient, especially when you're dealing with scenes that have an insane amount of detail.
The old graphics pipeline was like a really long, really strict factory assembly line. Every single tiny triangle that makes up an object had to go through every single station on the line, whether it needed to or not. It was super inefficient. The new pipeline with mesh shaders is more like a modern automated workshop. It's this dynamic 2-step process that can intelligently handle just a mind-boggling amount of detail without ever getting bogged down.
So how does it pull this off? First, a new stage called an amplification shader acts like a bouncer at a club. It looks at every single object in the scene and immediately throws out anything the player can't even see, like an enemy hiding behind a giant wall.
This is called culling, and it stops the GPU from wasting time rendering stuff that's invisible. Then, it takes all the visible objects and breaks them down into these tiny, manageable chunks called meshlets, and the GPU just chews through all of them at the same time. It's what we call massively parallel, and it is incredibly fast. Okay, so that's a lot of tech talk. Shaders, meshlets, culling. But what does all of this actually mean for you, for your gaming experience? What is the real-world payoff here?
Oh, the benefits are huge. For starters, in VR, a rock-solid high frame rate is absolutely critical to stop you from feeling motion sick, and these tools make that possible. If you're gaming on a laptop or a handheld like the Steam Deck, all this efficiency means much longer battery life. For everybody, it means games with a level of detail that was impossible before. Imagine thousands of individual leaves on a single tree, all rendered in real time without slowing the game to a crawl. It even helps mid-range PCs run modern games better. And beyond gaming, it allows architects and engineers to walk through their enormous 3D models as if they were real.
Now, as incredible as all this sounds, these technologies aren't some kind of magic bullet. They do come with a few specific requirements and, yeah, a few potential risks that you should probably know about. First up, you need the right gear. A modern graphics card that actually supports these features plus up-to-date drivers. And here's the really big one. Game developers have to choose to code their games to use these tools. It doesn't just happen automatically. And if a developer doesn't implement them carefully, there can be downsides. If they get too aggressive with VRS, you might start to see some blocky-looking shadows. And a bad mesh shader implementation can cause objects to flicker or suddenly pop into view out of nowhere, which can be pretty jarring.
So at the end of the day, VRS and mesh shaders really represent a massive shift in thinking, from brute force power to intelligent efficiency. They're giving developers the freedom to create worlds that are denser, richer, and more detailed than we've ever seen before, and they can do it while keeping things running smoothly. It finally breaks that old compromise between beauty and speed. And that just leaves us with one really exciting question. With tools this powerful, what kind of impossible worlds are we going to get to explore next?